Hello, geometry. Today we're going to do the chapter that we skipped to make sure we got to 11. We're going to go backwards now, back to 10, chapter 10. Just because we wanted 100% to make sure we got to 11, and we did get to chapter 11. So now we're going to do chapter 10. And again, from the update, I'm going to do my lessons here, and then I'm going to do some homework help on Zoom. That homework help is mandatory to arrive. And in that homework help, I'll do a couple of example problems. But this is going to be where your like information slash lesson is, and then the homework help is going to be where the examples are. At least a lot of worked out examples. I'll still do examples in this part of the video. Okay. But like I said, Zooms are mandatory to the year's end, otherwise, unless I otherwise state. Okay. So 10.1 tangents. So like I said, we're going back to chapter 10. Now, before we even talk about tangents, this chapter is all about circles, okay? All right. So let's talk about a couple of things we already know. From the center to the edge is the radius. We know that, and we know that for sure because from your test. From edge to edge that passes through the center, that's a diameter, okay? Something else we already know. Here's a new word, and I'll put all the vocabulary into like the Google Classroom's description. So you don't have to, like, I don't have to waste time writing it down. But this right here is a chord, okay? So this right here is a chord. A chord is a line inside the circle that doesn't pass through the middle. Notice it goes from a circle to the edge of the circle to the edge of the circle, but doesn't hit the middle. A diameter happens to be a chord that does hit the middle, while a chord is just a line that hits edge to edge without hitting the middle. For example, so it has to hit an edge of the circle, and the other end has to hit the other edge of the circle. If it was like floating in space, like this one right here, that wouldn't be a chord. Okay. So first new one is chord. So it's a line inside the circle that hits edge to edge. There's two other new words. If you use your circle, let's say a line that goes through, in and out of the circle, like this. So it goes into the circle and right out of the circle. That is called a secant. And that might sound familiar. Actually, I don't remember. That's from the trig stuff, secant. Purposely, they have the same name and do have a relationship. We don't really talk about it in this chapter, but they do have a relationship to the trigonometry secant. But secant is from here to here. Important, it goes inside the circle and pops back out. It's from the outside, inside, outside. Chord is just inside. So this little piece right here, let's say AB, right? If I said line segment AB, that's a chord. If I say line AB, now this is chapter 1 stuff, so this is a true callback. This is a secant. Okay? So look at the difference. Line segment AB is a chord. Line AB is a secant. Next one, we have a line that just hits it exactly once. Let's see. That hits the circle just exactly once. Like scrapes by it. Yeah, that's a pretty good one. This is the most important line we're learning about today. It hits the circle exactly on the edge exactly once, okay? So it just scrapes by. It just scrapes by the edge. That is a tangent. Has a relationship to the trigonometry tangent, but I don't think we go over that. So secant hits it twice, goes in and out. Tangent hits it once, right at the edge, okay? So those are the new terms today, and let's see what we're going to do about it. Okay, we're going to hard cut right to this example right here. You could pause the video and copy it down. I'll move it up a little bit more like that. Now, if you're finished pausing, we're going to go to a couple of problems here. Okay, now you copy down this. Now on this left, what we're going to do is identify what type of lines there are using the terms we just learned. Let's start with AC. AC is from the center to the edge. The center to the edge, it should be an old word to you, radius. Definition of radius is from the center to the edge of the circle. Line segment AB, so it goes from edge to edge of the circle. So is it a chord or is it a diameter? The difference is if you go through the middle or the center of the circle, that is a diameter. So this is a diameter. Okay. DE. DE is a line. They say ray DE. Doesn't really matter though. Ray DE, which is going this way, is a ray that's going to scrape only the circle once exactly at B. Now, you're going to assume that if it's drawn to show that it scrapes the circle once, you're going to assume it scrapes the circle once. So assume like there's like a particle hidden here or here. So D to E only hits the circle once on the outside, so that would be a tangent. And then AE. AE is a line that goes from the outside to the inside to the outside again. So that's a secant. Okay, so those are just identifying the types of lines. Now we're going to go to using some of the tangents. All right, so we're going to talk about properties of tangents. Here's one property. The radius of a circle and a tangent of a circle, so it could be like one way or both ways, but very important, doesn't matter. But a tangent of a circle and a radius of a circle always form a right angle. So that is a very important note. I would write that down if you do take notes. The radius and the tangent forms a right angle. So since it forms a right angle, what we can do is take a line from here to here, from tip to tip. And notice here to here is also a radius, by the way. But this whole shape looks like a right triangle. What does that allow me to do? Well, it allows me to do a little theorem called the Pythagorean theorem. And we could find a couple of missing informations from this situation. So, what are one example we could do? Okay, so if we have a question like this. So if we have a question like this, 50, hold up, let me make the question nice. R and R. So we have a question like this. We have 80. We know this segment right here is 50 to 50. And we have R and R here. What are we going to be forced to do in this situation? I want to find the radius, right? I don't give you the area. I don't give you the circumference. All I give you is this random tangent and this radius going to another point. The same point. Well, I know this is a right triangle, so I could do a little bit of Pythagorean theorem. So let's see if we could use that to our advantage. So first off, which one are the legs? It's the one across the right angle, so this one and this one. So you have radius squared plus, which is a squared in this case, plus 80 squared, that's b squared, equals, what's the whole line here, the hypotenuse? It's not just 50, it's not just r. It is 50 plus r squared. Okay, what are we going to do with that information, 50 plus r squared? Well, r squared and 80 squared, I'll just leave it like that for now. If you want to, you could do 80 squared and you get 6,400. But over here, we got 50 plus r squared. Now, very important, if I see 50 squared plus r squared, that's 100% incorrect, and I will mark points off for that. Instead, you have to do this. Rewrite this part as 50 plus r times 50 plus r. Now we're taking some old algebra skills and we're going to have to FOIL. So we're going to go 50 to 50, 50 to r to 50, r to r. So we're going to FOIL it out. Okay? If you want to practice FOILing, pause the video. But the answer is 50 times 50 is 2,500. R times 50 is 50, plus r times 50 is 50. Add that together is 100r plus r squared. So what's really difficult about this? Well, now you have to FOIL back out, so we have to think of it like that. All right. Now, let's see what we got. Let me just rewrite it. R squared plus 6,400 equals 2,500 plus 100r plus r squared. Well, you're a little worried because to find an answer for r squared, we might have to use quadratics. But what's really nice is there's an r squared on the right and an r squared on the left. So I can minus r squared on both sides, and they both cancel out. So now all I'm left with is 6,400 equals 2,500 plus 100r. Now I could just subtract the normal numbers. And I get now 3,900 equals 100r divided by 100 divided by 100. Altogether, r is going to equal 39. Okay? So here's the answer to the equation and all the work. Sorry, I ran out of space in the right corner. I should have just used the left more. But notice that in this situation where we're forced to FOIL out. All right, here's your next zero. If you have two tangents coming from the same circle and they both hit the same point, so they're tangents coming from the same circle and they're both hitting the same points, then this length is going to be equal to this length. Let me put some letters though. So AT is going to equal or be congruent to BT. So how do we use that information? Well, I could give you a quick example. 2x plus 5. Let's make this 17. So if I know AT is equal to BT, or two tangents are equal, then what that allows me to do is do 17 equals 2x plus 5. A lot easier than that last question. Do a little solving. 12 equals 2x. Divided by 2 on both sides, 6 equals x. Okay? So if they're equal to each other, you can set the two equations equal to each other. That's much easier. Maybe I should have started off with that one versus the last one. Okay, I'm done with what I wanted to teach. Make sure to show up to the Zoom. They are mandatory. You don't need the camera on. You don't necessarily need to participate, but just showing up and having your name on the list so it helps your classwork grade. Especially if anyone feels like they didn't do so well, that's the best thing you could do. Homework will be posted along with this video, and I hope to see you again at like 10:10 probably.